Okay, I failed to estimate how much more is left, so here we are with at least one more podcasts. Oops, sorry. So let me put it in display mode and then I can bring up the pointer. We are here discussing in Annex 2 the costs of making infrastructure more resilient. Considering the extreme event, cyclone, sea level rise, infrastructure in various forms is going to be a big part of the adaptation to climate change. The current climate is already a source of risks for physical infrastructure that should be addressed, not so unsurprising. Vulnerabilities to floods and storms have been estimated to be the costliest source of climate risks in the present. However, starting by addressing the existing vulnerabilities is the most practical step forward rather than trying to plan for future, because there are uncertainties, plus most of the impacts are already here, as we said, and it's not expected to change much more dramatically in the near future. Of course, you have to remember the time scale of the infrastructure you are building when you say that. Plus, there are people, as we said in the previous podcast, arguing for tipping points, etc. So we can't plan for such shocks, which are hard to predict anyways. Hence, we focus on the cost of strengthening existing exposed economic assets and investment projects to improve their resilience to floods and storms. Okay. We estimate upgrading costs with a systematic cross-country bottom-up approach. This approach is based on country exposure to natural hazards and the additional costs that would be incurred to make exposed assets more resilient. Obviously, it doesn't make sense to look at global averages of natural hazards and resilience. These are very much local, at least country level problems. We proxy the location of all infrastructure with the location of roads and railways. So they are just simplifying the situation, saying roads and railways represent most of the infrastructure exposed to risks from climate as we can plan for now. To identify which assets need strengthening, we use two detailed global maps. One shows the location of natural hazards and the other the location of roads and railways. The share of exposed assets by country is approximated by the share of the kilometers of roads and railways that are exposed to natural hazards. A kilometer of road or railway is assessed to be exposed if its construction standards are such that it gets damaged at least once every 100 years. So there are many assumptions here that one must be aware of. Construction standards are assumed to differ between high-income countries, upper-middle-income countries, and all others, and to increase with income following. Okay. The incremental costs of making exposed assets more resilient are estimated using the average values corresponding to the set of technical options from this paper here. So let's read off a couple of bullet points under that. Based on the exposure and incremental cost measures, we estimate the following: strengthening costs for investment projects. Okay, so there are again assumptions. When projections are unavailable, we assume that future investments to GDP ratios remain constant at the last observed level in the IMF investment and capital stock dataset of 2019. Achieving the sustainable goals would require additional investments. Those would need to be made more resilient and add to the cost. The costs are expressed in annual values. Details, but these are important in terms of assumptions that give you ideas of adaptation investments in resilient infrastructure. Strengthening costs of existing assets are computed as the capital stock that won't be depreciated by 2030, which was 10 years when the report came out. By now it's only 6 years, multiplied by the estimated share of exposed assets and by a unit cost of 50%. The total costs are annualized by assuming constant investments in percent of GDP over the next 10 years, which obviously hasn't happened since the report came out. We use the 2017 levels of public capital stock and the depreciation rates of the IMF investment and capital stock data set again. So depreciation or discounting is always a part of this for the future calculations. In some cases, it may be more cost effective to abandon some exposed assets or tear down and build them better. The fraction of the capital stock that won't be depreciated within 10 years is equal to 1 minus delta to the 10, where delta denotes the depreciation rate. It's a very specific empirical relation that you can look up for details in the IMF dataset. The simple cross-country average of adaptation costs is estimated at 0.1 and 0.3% of GDP for strengthening investment projects and existing assets respectively. These estimates are similar to the weighted averages presented in the main text, etc. So I won't go into the details, but you can just keep those numbers in mind. The cost estimates of strengthening public assets vary considerably across nations. This is estimated. This can be expected. Assets and investment projects in low-income countries and small developing states tend to be most exposed. They're more vulnerable to climate change impacts, thereby leading to high cost estimates. The costs are the highest for emerging economies because they typically combine larger exposure, as in low-income countries, and small developing states with large stocks of existing assets and investment projects. So the regular development projects are going full steam with infrastructures, not just roads and trains, but hydroelectric dams, energy infrastructure, housing, business enterprises, urbanization, etc. So they have more assets exposed to climate change. This is the issue. Okay, strengthening exposed future and existing private assets could cost respectively 0.4 and 0.6% of GDP annually between 2021 and 2025, which we discussed a little bit before, but here is a figure. Adaptation costs to selected current climate risks in the private sector over 2021 to 2025 as annual costs of strengthening private assets resilience to current storms and flood risks. These will change, but as we said, the assumption is that they won't change very drastically in the near future, at least in terms of the life cycle of the infrastructure we are talking about. So again, talking about various regions that we mentioned before: low-income countries, small developing states, emerging economies, and advanced economies. So strengthening new projects and strengthening existing projects, as we have said before, in terms of percent of GDP, strengthening existing assets can cost much more over this period of 2021 to 2025 than strengthening new projects, because projects that are being implemented can take into account the safety factors and strengthening requirements to make them more resilient, whereas existing assets have to be retrofitted, which typically tends to cost more. So should I just wrap this up, or maybe I should come back and do another podcast? So we keep adding podcasts, but that's okay. This one is a bit short at 8.5 minutes. That's just fine, right? So I'll see you in the next podcast.